ना, इसमें तो कुछ किया ही नहीं आज हमने ज्यादा यार। भेजना है पीडीएफ क्या?
पीडीएफ लेसन
अच्छा हाँ मिलेगा। लेकिन सुनो, तुमको जो है एटॉमिक में लेक्चर बाय लेक्चर पीडीएफ मिलेगा, वो तुम्हें कल मिल जाएगा। एक्चुअली वो कंपाइल नहीं है, एक एक लेक्चर अलग अलग है।
ओके सर,
ठीक है, वो हो रहा है, वो तुम्हें कल मिल जाएगा। ठीक है, थोड़ा वेट करोगे। ठीक है, चलो भाई, थैंक यू
थैंक यू
बाय सर, थैंक यू।
बाय बाय। ओके,
थैंक यू सर।
बाय सर।
बाय बाय। बस जा रहा हूँ।
बाय सर।
हाँ, ज़ील कहाँ है यार, पता नहीं। एक बार रुको, जाओ तुम लोग ब्रेक लो अपना।
So students, your chemistry lecture is over. You have a break of 15 minutes. Okay, so I'll give you 15 minutes of break, and then we'll start with the physics lecture.
Vectors, I hope. Or how many of you have not yet done vectors? Hello, can you hear me? हाँ, नहीं, जितना मैंने कराया था उतना तो किया ही हुआ है, बट उसके आगे किया है कि नहीं किया है? ओके, ठीक है। ठीक है, तो मैं यहाँ पे I'll be very quick and I'll complete the topic very quickly. Okay. So the question that I want to ask is that how many rectangles can we draw for which this vector will be a diagonal? How many rectangles can we draw for which this vector will be a diagonal? How many rectangles can we draw for which this vector will be a diagonal? Right? All you have to do is just type in, yeah. How many vectors can you draw for which this vector will be a diagonal? I want everybody to type in an answer, please. I am looking at the answers. How many? Very nice. Well done. Good. Yeah. So basically, what happens is that. Oh, sorry. Basically, what happens is that I draw, or I can draw the x-axis, y-axis. Y-axis takes any one, y-axis, right? And then what I can do is I can say that, look, if I were to visualize a rectangle which is like this, I draw perpendiculars from the head of the vector. So vector this along the x-axis and this vector along the y-axis add up to give me the vector A. So this is a rectangle for which the vector is a diagonal. However, I can draw an xy axis any which way I want. Okay, and if I do that, then I get this vector plus this vector is equal to the black vector. So let me call this the x-axis, let me call this the x dash axis, and let me call this the y-axis, and let me call this the y dash axis. So again, I would like to ask you, for those of you who are correct, good, very good. Again, I would like to ask the question, how many rectangles can I draw for which this vector will be, this vector A will be the diagonal? How many rectangles can I draw? Yeah, so the answer is I can draw infinite rectangles. Yeah. Okay. So, yeah. So now, see, if I have any number, then I can write the number like this, okay? Or I can write the number like this, or I can write the number like this. Right? In our daily lives, we do not prefer to write numbers like this, or we do not like to transact with numbers which are expressed as the sum of two other numbers. For example, if you go and buy something from the market, the vendor is not going to say that, sir, the total is 40 plus 50 rupees, that is 90 rupees. The vendor is just going to say that the total is 90 rupees. So in our daily lives, we do not like to express a number as the sum of two other numbers. Basically, it is not practical, it is not useful, but it can be done. Okay. So I can have here 5.5 plus 3.5, or maybe I can have 5.4 plus 3.6. Okay, so now I would like to ask you the question. How many pairs of numbers will add up to 9? How many pairs of numbers will add up to 9? Yeah, infinity, right? Infinity. Yeah. Next question. How many pairs of numbers will exist between these two green lines that add up to 9? How many pairs of real numbers add up to 9 between these two green lines? Yeah, you understand? Okay. How many pairs of integers add up to 9? How many pairs of integers add up to 9? How many pairs of, no, not between the line, between the line to koi integer hi nahi hai na. I'm talking generally. How many pairs of integers will add up to 9? Integer की बात हो रही है, positive भी हो सकता है, negative भी हो सकता है. हाँ, so the answer of course will be how many pairs of real numbers between any two set of integers adding up to 9 will also add up to 9. Okay, you understand my question? It is just like the green line wala question. How many pairs of integers, how many pairs of real numbers between any two consecutive pair of integers will also add up to 9. The answer will be again infinite. So if I were to talk about a number A, which is the sum, or which is the number of pairs of integers that add up to 9, and B, it is the number of pairs of real numbers which add up to 9. Which number is bigger, A or B? Which number is bigger, A or B? सेम सेम क्या बोल रहा है भाई? सेम कहां से हो जाएगा? सेम होएगा. Which number will be bigger? A is the number of integers. A is the number of pairs of integers which yeah. तब भी सोचने में क्या लगता है? सोचने में कुछ तो लग रहा है. A greater than B होएगा कि B greater than A होगा? So the answer is that they will be equal, right? I mean, this is the great conundrum. This is the great mystery of infinity. That no, I did not say incorrect. मैं तो केवल I was just testing you. कि are you sure about the answer? I did not say it was incorrect. No. You are absolutely right. So this is the great mystery of infinity, you know. I mean, you can go up to you can you can go up to large, you can go up to any number which is very large, and you will still be as far as infinity as you were before, right? So my next question is how many pair of vectors? Okay, so this is supposing one vector, and so I draw the parallelogram, supposing the other vector. How many pairs of vectors will add up to vector A? How many pairs of vectors will add up to vector A? Right. So the answer is infinite. Yeah. So number of pairs is equal to infinite. And the next question is how many pairs of vectors which are mutually perpendicular to each other? This is very important. How many pairs of vectors which are mutually perpendicular will add up to A? So number of perpendicular pairs that add up to the vector A. Kitna hoega? How many number of, yeah, so this will also be equal to infinity. Right, great. So it turns out that if you have two vectors, let's call them AX and AY, who are mutually perpendicular to each other, and they add up to vector A, then AX and AY are called component vectors of A. Right? Okay. So this is the definition of something very, very important, something that is going to stick with us for a very long time, and that is component of vectors. Right? So the way to define component of vectors, I'll come back to this diagram. So the way to define components of vectors is that you will choose two mutually perpendicular axes and you will find two vectors which lie along this axis, right? And these two vectors should add up to the original vector. Then the component vectors of the original vector are ax and ay, or in this case a dash x and a dash, ax dash and ay. So if we have an xy axis and if we have a vector a, then you can drop a perpendicular from the head and tail of the vector A onto your chosen xy axis, and this will give you the x component and this will give you the y component. Now there is a problem. The problem is that whenever I use the word component, okay, it may mean scalar, it may mean vectors. Basically, when we talk about a component, we are really talking about a scalar quantity. But when we add up two vectors, as you will see later on, when we are going to add up two vectors and when we are going to express a vector in I cap j cap form, then the vector component, then the vector component will be the vector along the axis, right? This is a vector component. This is a vector component. हाँ, कौन सा स्लाइड देखना है भाई? ये वाला स्क्रीनशॉट ले लो, टेक अ स्क्रीनशॉट, टेक अ स्क्रीनशॉट. कभी कभी मेरा कनेक्शन जो है वो उड़ जाएगा और फिर मैं then I will not be able to share with you the screenshot. So please take a screenshot of this, like today morning. Yes, like today morning. फिर उसके बाद से ये तो ऐसे ही बताया मैंने कुछ, फिर उसके बाद से ये. Right, so components can be scalar or components can be vectors, right? And there are some properties of components which you must remember. Very, very easy. So the first property, this is important, properties of components. So the first property is that the vector ax plus the vector ay is equal to the vector a. Components always, the two components always add up. So here this would be ax, this would be ax, this would be ay. The second property is that if this angle is given theta, right? This angle is given as theta, then we can write the vector ax, the mod, is equal to vector a, right, multiplied by cosine theta. and vector ay ka mod is equal to vector a ka mod multiplied by sine theta, right? From the right angle triangle we can work this out. And the third property, which again should be obvious, it's just Pythagoras theorem, is that क्या ax होएगा? हाँ ये ax ही है basically, मैंने stylus कभी-कभी. So the third property is that ax square plus ay square is equal to a square. Right? So Pythagoras definition of sine theta cosine theta and the definition of addition of vectors, this gives you the component vectors. Now the thing is that if you have a vector like this and a vector like this and a vector like this and a vector like this, then if this is the vector a1 and if this is the vector a2 and if this is the vector a3 and if this is the vector a4, right, then what we are going to do is we are going to say that the component of the x component of vector a1 and the y component of vector a1 will both be positive. Here we will say that the x component of the vector a2 and the y component of the vector a2, the x component will be negative whereas the y component will be positive. Here we will say that both the components, the x component and the y component, will be negative. So basically what is going to happen is that I am going to ask you कि ये A3 vector है, इसके components बताओ क्या होंगे? So you will have to give me two numbers, right? And both these numbers will be negative. What is this negative number telling me? Yeah, according to the sign of quadrant. So what is this negative number basically telling me? It is telling me that, look, the x component is pointing towards the negative x-axis and the y component is pointing towards the negative y-axis. Yeah, it is telling me the direction. So here we will get a4x is equal to positive, whereas a4y will be equal to negative. Okay. Chalo. So let's using this, let's try a question. So we have the xy axis. We have the vector A. क्या हुआ? हैंड रेज किया था किसी ने, फिर लोअर कर लिया. So we have the vector A, right? And this angle is 45 degrees. This is the x-axis, y-axis. I'm telling you that mod of A is equal to 5 units. I don't need to write units because we are discussing maths at the moment. So the question is, find xy components of vector A. हाँ, so मतलब पहला वाला तो बहुत ही इजी है ना, मतलब इट इज लाइक या पहला वाला बहुत ही इजी है. मेरे को आगे लिखने दो. लेट मी राइट द नेक्स्ट पार्ट ऑफ द क्वेश्चन. Right, so the first one is very easy. The answer is 5 by root 2 and 5 by root 2. So now what I do is I take the xy axis and about the z axis, I twist it anti-clockwise by 8 degrees. Right? Ha. Now you have to find the components. So B का answer बिल्कुल सही. Sin 37, 5 by cos 37 नहीं आएगा. It won't be 5 upon cos 37. हाँ. Cos 53 और sin 37 का सेम वैल्यू होता है. Cos 53 and C along Y is, हाँ बिल्कुल सही. हाँ हाँ. ये क्या है ये 5 cos 50 5 48 48 कहाँ से आ गया? हाँ ये सही है. ये सही है बिल्कुल. हाँ. नहीं नहीं, सी में दोनों इक्वल नहीं होने चाहिए. दे कैन नॉट बी इक्वल इन सी. क्या हो गया भाई? 5 बाई रूट 2 कैसे आया? 5 cos 45. ये हमने परपेंडिकुलर ड्रॉप किया. ये एक्स कंपोनेंट होना चाहिए. इसका लेंथ 5 है. मैंने आपको ये दिस इज गिवन टू यू. हाँ, आई मीन यू कैन से इट इज द फर्स्ट प्रॉपर्टी और सेकंड प्रॉपर्टी. आप अगर वैसे याद रखना चाहते हो वैसे याद रख सकते हो. लेकिन मैं आई ऑलवेज ट्राई टू रिमेम्बर इट एज ए राइट एंगल ट्राइंगल. राइट, राइट एंगल ट्राइंगल में एक एंगल और हाइपोटेन्यूज दे दिया तो आप बाकी साइड से निकाल सकते हो. I'm more interested in E and D and E. बताओ भाई D and E का क्या आंसर होएगा? नहीं वर्कआउट किया? Yes, the initial angle will be 45 degrees in each case. Yes. I am always turning from the initial point. Okay, I don't. It is not कि मैंने 8 डिग्री से किया. हमेशा anti-clockwise. Always anti-clockwise. So I've not written because number one, I don't have the space, and number two, बिल्कुल जैसे पहले लिखा है वैसे ही होना चाहिए. For D, AY will be excellent. Yes. हाँ पूछो भाई. हेलो
सर वो जो आपने प्रॉपर्टी बोली ना, मॉड ऑफ नहीं सॉरी, ए वेक्टर इज इक्वल टू,
फिर से बोलो, फिर से बोलो, say it again, say it again. फिर से बोलो. एक मिनट रुको. Okay, so I'll tell you the answers. इसका आंसर है 5/√2, 5/√2. 8 डिग्रीज वाले का आंसर है x कॉम्पोनेंट ax एंड ay. हाँ, वेक्टर ax और वेक्टर ay का सम वेक्टर a होना चाहिए, राइट. तो इसका होएगा 4 and 3, राइट. और ये 15 वाला जो है इसका होएगा 5√3/2 and 5/2. इसका होएगा 5 and 0. और ये जो 75 डिग्रीज वाला है इसका हो जाएगा 5√3/2 -5/2. ओके. बेसिक ट्रिग्नोमेट्री है भाई, कोई उसमें कोई डी वाले में जो एक्सिस है ना, मेरी डी वाले में एक्सिस चली गई है. और जब एक्सिस अलोंग द वेक्टर हो जाता है तो वेक्टर जिस एक्सिस के अलोंग है उसका कंपोनेंट उस एक्सिस के अलोंग उसी वेक्टर के इक्वल हो जाता है और दूसरी एक्सिस के अलोंग 0 हो जाता है. चलो भाई, नेक्स्ट. So if we have a vector A, okay, and I'm telling you that the x and y components of vector A. So if I were to drop a perpendicular here, this would be the x coordinate. If I were to drop a perpendicular here, this would be the y coordinate. Now what I do is I take another axis. Let's call this x dash and y dash, such that this angle is equal to theta. And obviously now for the blue line, the components would change. So let's call this x dash, let's call this y dash. या सबको समझ में जो मैंने डायग्राम बनाया है, this is understood by all the people. This diagram that I have made is understood by all. Yes, all you have to do is type yes when I ask a question, right? I mean, इतना तो सब लोग कर सकते हैं ना, yes or no type करना है. Is this diagram understood by everyone? Yes or no? Type yes or no. Now, using your knowledge of trigonometry, okay, using your knowledge of trigonometry, can you tell me what is the value of x dash and y dash in terms of x, y, and theta? Can you tell me the values of x dash and y dash in terms of x, y, and theta? Right. So the answer that I am expecting is something like x dash is equal to y dash is equal to, and here we have some x, y, and theta. Here we have some x, y. Can you tell me what are the values of x dash and y dash in terms of theta and x and y? Using your knowledge of trigonometry, let's see who comes up with this first. No, x dash is not x upon cos theta. No. X dash is definitely not x upon cos theta. x cos 90 कितना होता है? x cos 90 cos 90 कितना होता है? cos 90 तो 0 होता है. x cos 90 plus theta तो theta हो जाएगा. नहीं? अच्छा, you are saying x cos 90 plus theta. नहीं 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 नहीं. The angle between y and y dash is theta. Yes. Yes. हाँ क्या आंसर दिया भाई? x dash is x cosine 90 minus theta. नहीं 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 नहीं, x cos phi upon cos theta cos phi sin theta. phi कहाँ आ गया? phi क्या है? phi कौन सा एंगल है भाई? tan inverse of x by y. Tan inverse of ओ नहीं 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 उस एंगल ओफो नहीं 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 उस एंगल में जाना ही नहीं है, वो एंगल गिवन ही नहीं है, उसको अज्यूम करो तो नहीं गिवन. Forget about that angle. Only work with triangles having angle theta. No other triangle. चलो एक मैं करके दिखाता हूँ. वेक्टर कहाँ से आ गया भाई? तो हम लोग केवल कंपोनेंट्स का ट्रांसफॉर्मेशन देख रहे हैं ना. सो इफ दिस is x dash and if this is x, this angle is theta and this is x and this is x dash. Look, I'm just trying to show you how to do this. So let me do it in yellow, right? All my calculations are in yellow. ये distance कितनी है? ये distance x है. तो मेरे को यहाँ पे एक राइट एंगल ट्राइंगल दिखाई दे रहा है. साइन y tan y कहाँ से आ गया भाई? tan y नहीं नहीं नहीं, ये वाले राइट एंगल ट्राइंगल में देखो तो ये डिस्टेंस कितनी आएगी? अच्छा y is theta. Oh. ये डिस्टेंस कितनी आएगी? tan theta is equal to unknown distance upon x. So this must be x tan theta. इसके बाद से ये डिस्टेंस कितनी आएगी? What is this distance? ये डिस्टेंस कितना होगा? Well, cosine theta is equal to x upon hypotenuse, right? So hypotenuse must be x upon cosine theta. So this distance is x upon cosine theta. Now, if only I could figure out this distance, then I can add it to x by cosine theta. And that's it. My job is done, right? If this angle is theta, then what is the value of this angle? ऊपर वाला angle, ये भी theta होएगा, right? And you can work this out very easily. If that above angle is theta, right? Then how can I figure out what this yellow line is? All I need to do is figure out this yellow line and add it to x by cos theta. That will give me x dash. So x dash is equal to x upon cosine theta plus something which I don't know, right? What I do know is that this distance is y dash, but I don't want to go in terms of y dash. I cannot write the distances in terms of y dash and x dash. The distances have to be written in terms of x and y, right? So you see, then I go for the next. I go for this distance. And what is this distance? This distance must be surely y minus x tan theta, right? Because if I were to drop a perpendicular here, then this whole distance is y, and y minus x tan theta is the is the hypotenuse of this right angle triangle. Okay, so what is the length? What is the solid yellow line? What is the length of the solid yellow line? Well, we have sine theta, okay, is equal to the unknown side divided by the hypotenuse, which happens to be y minus x tan theta, right? हाँ, तो अब unknown side कितना हो गया? What is the unknown side? The unknown side is y sine theta minus x tan theta into sine theta. And what is tan theta into sine theta? Well, tan theta I want to write as sine upon cos. So this will become sine square theta upon cos theta. So what is the thing that I'm adding in the brackets to find x dash? I'm adding y sine theta minus x sine square theta, sorry, thoda sa, divided by cos theta. Can you tell me the answer to this? What is x dash? What is x dash? X dash is equal to, what is x dash? तो ये वाला x का टर्म और ये वाला x का टर्म ऐड करेंगे, दोनों में LCM तो वही है, मतलब दोनों में डिनोमिनेटर तो सेम है cos थीटा, तो ऊपर क्या आएगा न्यूमरेटर में? You'll get x minus x sine square theta. You can take x common. You'll end up with 1 minus sine square theta. And what is 1 minus sine square theta? X cosine square theta. नीचे भी cosine theta है, ऊपर cosine square theta है, तो मेरे पास ऊपर आएगा x cosine theta. Yeah. Right? I have found x dash. Now, can you find y dash for me? Can you find y dash for me? Can you find y dash for me? Y dash अब एक step में आ जाना चाहिए. Y dash should come out in one step now. X sin theta, y cos theta. नहीं, हाँ ये आएगा y cos theta minus x sin. क्या हुआ भाई? बाकी लोग निकालो जल्दी से. ओ भाई नहीं हो रहा है. देखो, नहीं 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 नहीं, देखो y dash y dash is equal to y dash is equal to, ये हाइपोटेन्यूज है y माइनस एक्स tan थीटा, और मेरे को तो ये साइड निकालना है और ये एंगल थीटा है, तो मैं लिखूंगा कोसाइन ऑफ थीटा इज इक्वल टू y dash upon hypotenuse, right? So y dash is equal to hypotenuse into into cosine theta. So we get y minus x tan theta into cosine theta, right? Which will give me y cos theta minus x sin theta. So let me just rewrite the results. So if you have a vector A, which is making some angle, with the x-axis, y-axis, I don't know, and I'm not really bothered, right? So we have a vector A for which the x component and the y component are known, right? X component and y component are known to us. If this is the case, and if I were to rotate the axis, okay, and I were to rotate this axis anti-clockwise by an angle of theta, keeping the z-axis same. अभी z-axis पे आता हूँ मैं एक मिनट में. Keeping the z-axis the same, then the new components ax dash and ay dash, okay, they would be equal to, new components ax dash and ay dash would be equal to exactly the same transformation that we got here. Exactly the same transformation that we got here. So they would be equal to the original x component into cosine theta plus the original y component into sine theta. A dash y would be equal to minus ax sine theta plus ay cosine theta. Now, when we were starting with vectors, I told you that there are three conditions that a vector satisfies. A vector has magnitude, a vector has direction, and I told you that I'll tell you the third condition later on. This is the third condition. So a vector is a vector if it has magnitude, if it has direction, and okay, and if I rotate the axes, in physics it is called transforming the axes. If I were to transform the axis in this way, then the components would definitely transform in this manner with this equation. If they do, then you are dealing with a vector quantity. And if they don't, then you are not dealing with a vector quantity. For example, current is something which has magnitude, it has direction. But if you were to rotate the coordinate axis of the current, it would have absolutely no effect on its components. And since the components of current, which itself is not defined, are not following this criteria, are not following this transformation equation, they are not vector quantities. Okay? So current is therefore not a vector quantity. This is the third condition, right? Okay, so what I wanted to really talk about in this lecture was the concept of the components of vectors, right? So what we are going to do in physics, throughout physics, is that I am going to give you a vector quantity and you will be choosing an axis depending on the question. You may choose an axis like this. You may choose a normal horizontal vertical axis. Once the axis is chosen, then you are going to resolve the vector into its components. Right? So if this is the vector A, this is the x component of the vector, the y component of the vector, then this process is called the resolution of vector A into its components. And unlike the real world and unlike the practical world, where we do not like to express a number as the sum of two other numbers, right? So somebody asks you your age, then definitely you are not going to say my age is 10 plus 6. You are going to say 16, right? So just like in our real world, in our practical world, we do not express numbers as the sum of two other numbers. Turns out that in the world of vectors, it is always better to express the vector as the sum of two other vectors. Always. We will always express a vector in terms of other vectors, right? Okay. Next concept, why? Why? That's a good question. Why? So you see, the concept of vector addition is alien, and as you will see, the concept of vector multiplication will be more alien. So what we want to do is, at least for addition and subtraction, we want to express the vector in such a way that addition and subtraction will be as close to the operation of addition and subtraction in the arithmetic world. जिस तरीके से हमें क्लियरली 5 + 4 = 9 आ जाता है, उसी तरीके से यहाँ पे भी अगर मेरा कुछ जुगाड़ हो गया, मतलब कि मुझे पैरेललोग्राम लॉ नहीं यूज करना है, मेरे को ट्रायंगल लॉ नहीं यूज करना है, मेरे को पॉलीगन लॉ नहीं यूज करना है, अगर ऐसा हो गया, right, so things will become very comfortable for me. So if I express vectors as the sum of other vectors, it turns out, yes, because of the fact that vector components are in the same direction, अगर same direction में है, तो आप उनको as a normal number treat कर सकते हो, लेकिन अगर वो opposite direction में है, तो आपको उसमें minus sign add करके then you can treat them as numbers, right? Yeah. So basically, what will happen is that when you express vectors as the sum of two other vectors, randomly नहीं करना है, उसका एक specific तरीका है जो मैं भी बताने जा रहा हूँ. If that happens, then you can mimic the addition and subtraction to a level which is almost the same as the addition and subtraction in the numerical world.
So we can't absolutely tell the direction of any vector because we can always change the x and y axis.
If you look at the diagram that I have drawn, मैंने ब्लू एक्सिस ड्रॉ करी और मैंने ब्लू एक्सिस को टर्न करके रेड एक्सिस बना दिया. मैंने एक्सिस चेंज करी लेकिन जो ब्लैक वेक्टर है उस पे कोई फर्क नहीं पड़ा.
But sir, its direction with respect to x and x dash is different.
No. Absolutely not. The direction of vector A is absolute. वो ब्लैक एरो जहां पॉइंट कर रही है वो उस वेक्टर का डायरेक्शन है. उस वेक्टर के कंपोनेंट्स क्या हैं ये डिफरेंट हो गए. राइट. फॉर एग्जांपल, लेट्स से दैट I want you to walk to Delhi, but I want you to walk in a very special manner. That is, that you will walk in a straight line, and at some point you can take a 90-degree turn, and again you have to walk in a straight line. So two straight lines must be the totality of your journey, right? So will you agree with me that there are infinite number of paths from which you can reach Delhi?
Yes, sir.
है ना? लेकिन दिल्ली तो वही है, मुंबई तो वही है. मुंबई दिल्ली में तो कोई चेंज नहीं आया, बस आपके पाथ्स चेंज होते गए और आपने जो भी पाथ लिया है वो म्यूचुअली परपेंडिकुलर है. So some in one scenario maybe you walk north for some kilometers and then east for some kilometers. In another scenario you walked 30 degrees left of north some kilometers, and then you took a 90-degree turn and you reached Delhi. So in both these cases you have reached Delhi, but you have reached along two different paths or infinitely many paths, right? Delhi का absolute position, मुंबई का absolute position तो नहीं change हुआ, लेकिन आपने जो उस वेक्टर को which joins मुंबई and Delhi, उस वेक्टर को जो आपने कंपोनेंट्स में डिवाइड किया, सबने अलग अलग कंपोनेंट्स में डिवाइड किया. अगर 10 लोग अलग अलग पाथ पे गए तो सबने अलग अलग कंपोनेंट्स में डिवाइड किया. राइट?
यस सर, थैंक यू.
हाँ, और क्या पूछ रहा है? यस, विथ रिस्पेक्ट टू कोऑर्डिनेट सिस्टम ऑफ आवर चॉइस यू कैन ट्रीट इट एज ए स्केलर. यस, वेक्टर डायरेक्शन रिमेन्स सेम. ओके, चलो आगे बढ़ते हैं. लेट्स मूव अहेड. हाँ, now I want to talk about another weird concept. This is the concept of unit vectors. Now you see, up till now I have been very clever and I never talked about the direction of vectors. Okay, I never talked about the direction of vectors. हाँ भाई, बताओ.
Hello sir.
बोलो बोलो.
सर मैं 10-15 मिनट पहले से डिस्कनेक्ट हो गया था. आपने जो कुछ पढ़ा थोड़ा ब्रीफ में बता देंगे?
अब मेरे को क्या मालूम 10 मिनट पहले मैं क्या बता रहा था, लेकिन ये रिकॉर्डिंग हो रही है इस लेक्चर की, अभी रिकॉर्डिंग ले लेना.
हाँ हाँ चलेगा सर, ठीक है फिर. हाँ, थैंक यू.
Okay, so we are now talking about the concept of unit vectors, right? So I have not talked about direction as yet. I stayed clear of direction. Maximum मैंने क्या किया, मैंने बोला कि अच्छा ठीक है एंगल थीटा पे है कोई चीज, but angle theta is really inadequate because we are going to work in 3 dimensions. The moment you are in 3 dimensions, things become difficult. So, class का time कब तक है? 5:30 तक ही है क्या? 5:45 तक है ना? हाँ. Okay. So, I want to define directions, right? And to define directions, what I will do is I will use the concept of unit vectors, right? So the concept of unit vectors is that their magnitude is always equal to 1, okay? And their only purpose is to point out a direction. Okay, and there is a third property as well, which right now is not very important, but later on it will become very important. And that is that they are the only vectors in physics which are dimensionless, which is another way of saying unitless. Okay, so all vectors in physics have units. Force will have a unit of newtons, velocity will have a unit of meter per second, electric field will have a unit of volt per meter, magnetic field will have a unit of Tesla, and other vectors will have their own units. This guy, however, the unit vector, it will be absolutely unitless, dimensionless. Okay. So, let me just go back to this. Unit vector is unitless. मैंने पहले कभी सोचा नहीं था. Good. So, what I will do is that along my x, y, and z axis, I will define 3 unit vectors, right, which have the single purpose of defining the direction which lies along the plus x axis, the plus y axis, and the plus z axis. And since these vectors are used to define directions, I will give them a special name. Remember that their magnitude is 1, right? So I will give them a special name. And the names of these vectors are I cap, j cap, and k cap. Right? Therefore, these 3 vectors would be minus I cap, minus j cap, minus k cap. So at this moment now, you have knowledge of 6 directions. Standing anywhere that you are, you can define now 6 directions. These directions will be I cap, j cap, k cap, minus I cap, minus j cap, minus k cap. Using these random तो नहीं, नाम है I hat, I cap नाम है सर. I cap is a unit vector that points towards the positive x-axis. J cap is a unit vector that points towards the plus y-axis. And k cap is a unit vector that points towards the plus z-axis. That's it. और कुछ नहीं. हाँ, नाम जो है वो obviously yes, somebody must have thought of it, somebody must have said कि ABC यूज हो गया, XYZ यूज हो गया, अब क्या करें? तो उन्होंने बोला अच्छा ठीक है IJK यूज कर देते, क ख ग भी यूज हो सकता था, बट इंग्लिश यूज हुआ. So we have direction, we have knowledge of 6 possible directions, but that is not enough, because we know that there are an infinite number of directions possible. I want to arrive at a situation where I can point my finger anywhere and say that, look, this is the direction, and I can write down that direction with my pen on paper, right? So to do that, what we are going to do is that we are going to define, so this is the y-axis, x-axis, z-axis, minus z-axis. So we are going to define the vector I cap like this.